Hello, I'm Bryan O'Neal from Coherent. In this video, I'd like to show you something called a traffic director, which has been a very successful implementation pattern amongst a number of our insurance customers. What it lets you do is have one model in Coherent talk to another. And I'm just going to show you a few diagrams of how you might use this in the insurance context today. And in later videos, we'll get into the details of how to actually implement it. The feature that this pattern makes use of is something in Coherent called an Xcall. And an Xcall lets one model that you've uploaded to Coherent call another model that you've uploaded to Coherent. Lets one Spark service call another. All right. And that leads to a lot of interesting things that you can do. And this traffic director pattern is the first of them. So let me show you three different examples of traffic director patterns. The first one is going to be pretty simple. And it is basically using a traffic director to decide which version of a rater to call. So on my screen here, we have a core system on the left. Maybe it's a Guidewire or Duck Creek or Insurity or you name it. And on the right, we have a cyber rater with multiple versions that are live simultaneously, version 1, 2, 3, 4, and 5. And let's say that there's complex business rules deciding which version of the cyber rater to call. Like maybe a policy that was initially bound in 2022 that's coming up for renewal this month needs to use version 4. And then other new business needs to use version 5, et cetera, et cetera. That kind of business logic can get pretty twisted, and maybe you don't want to put all that business logic in your calling system. Maybe you'd like to put that in Excel itself, all right? So what you'll do is create a model here in the middle that you're going to call a traffic director, and its whole purpose is to look at the full superset of inputs from the core system and pass them on to the correct version of the cyber rater via Xcall, depending on things like transaction type or effective date or policy effective date. And it's going to, the traffic director is just going to have a little decision table that says, oh, based on this transaction type and this policy effective date, I need to use version 4 of the cyber rater. So it calls version 4, gets all the X outputs back, sends them back to the core system. Easy day. All right, let's look at a more sophisticated traffic director concept. In this screen, we see 5 algorithms right here in the middle, A, B, C, D, and E. And these can be anything. Like map this onto whatever you do day to day in the world. Maybe you're an actuary and you've got 5 different reserving algorithms, or maybe you are delivering some complex specialty lines product that has multiple coverage lines that you might or might not use. The traffic director in this scheme is going to look at all the inputs coming from the user, from the UI, and say, oh, I need to call algorithm D, for example, based on the inputs that I'm seeing. And it'll call algorithm D, and algorithm D will start processing and start doing its calculation. And then algorithm D in turn will say, oh, I've got an Xcall configured in here that says I need to call out to the expenses model, or I need to call out to the taxes model and calculate something there. So at this point, we've got 2 Xcalls, one between the traffic director and the one between algorithm D and all these other shared models, one of which, by the way, can actually be an external data source, which we'll cover in other videos. We call that an X connector pattern. All right, so at this point, you can see how the great advantage of doing this is that you only have to maintain all these bits of logic in one place. Like the taxes model over here could be massively reusable across many different services in your entire organization. All right, let's do one more. Here's a scenario that you might run into in a multi-state workflow. Let's say you've got like a commercial property policy that you're trying to price. The first thing you're likely to do is run it through some rules algorithms, some eligibility rules that, accept, refer, decline kind of stuff. So the traffic director is going to take the set of inputs from the core system again, and it's going to say, oh, this is a North Carolina property policy, and it is within a quarter mile of the coast, therefore I'm just going to decline this right out of the gate without even pricing it. Or it might say, okay, this is a North Carolina property policy and the distance from the coast is many miles, therefore we're going to go ahead and quote it. And the traffic director then will call the North Carolina rating algorithm, and it'll call the correct version, of course, as well, and return the premium back to the core system. And we can see why this would be advantageous. Number one is that it lets you have more real estate in your Excel model to actually build this rating logic. It keeps you from having a mega model that is difficult to maintain. But then the other reason you'd want to do this is if all these states have different rate filing dates, you don't want to be stepping on the toes of the South Carolina rate filing if you're trying to do the North Carolina rate filing, for example. So it really deconflicts work across teams. We're going to do some more videos that get into the details of how you would implement these patterns. But if you understood this, this is a great start, and we're happy to work with you on your particular use case. Thank you very much.